Hello everyone. Today let's solve the problem number 69, square root of x. Right. So what the question states here, we are given a non-negative integer x. So we have been given a non-integer x, a non-negative integer x. You can clearly see here on the input, right? So this is a non-negative integer they are saying, right? So we shouldn't consider any negative integer here. We have been given a non-negative integer x. We have to return the integer part of its square root. So we have to return the integer part of its square root, means we should not return the output in the decimal or the floating point integer, right? So we have to return the integer part of its square root. They have strictly mentioned in the question, right? Don't get confused here. So the output is a whole number here in this case, right? 2 here again, x equals 4, square root of 4 is nothing but 2, square root of 8, this one we have got, this one 2 here in this case, right? So the square root of 8 is 2 point something, and since we have found it down to the nearest integer, we will return the 2 here in this case, right? So don't get confused here. So we cannot use the built-in power or square root functions. They have strictly mentioned we cannot use the built-in power or square root functions, right? So we shouldn't use the built-in or square root functions. We can directly make use of the this one, built-in or this one, power or square root functions. So we shouldn't be using that. That's what they have said, right? So here we must return the floor or the actual square root, floor of the, sorry, we have to return the floor of the actual square root, right? Method floor in the sense, yeah, whole number. So this one, uh absolute number. So here in this case, we have been given a non-negative integer x. We have to return the integer part of its square root. We cannot use built-in power or square root functions here, and we must return the floor of the actual square root. So that's what they have given, right? I hope this part is completely clear, man. I hope this part is completely clear. Let's do one thing. Let's quickly discuss the this one, what do we call, approach accordingly with the question. Let's quickly discuss the approach followed by the complexities, and then let's write the code. So let's consider the second example here on this case, where x equals 8. We have to get the output 2, right, for this one. So we have discussed the both here, the first and the second example. Let's consider the second example here. So here in this case, we will be going with the binary search. Just keep this in mind. For this particular problem, we'll be going with the approach binary search. Just keep this in mind. So we will search the answer between 1 and x by 2. We will be searching the answer between 1 and x by 2 here using the binary search. As I've said, we'll be going with the binary search, right? So here in this case, mid is 4 by 2. So here in this case, 1 into x is nothing but here 8. 8 by 2 is nothing but 4 by this one. 8 by 2. 8 by 2 is nothing but 4. 4. 1 into 4 is nothing but we got 4 here, right? So here now this is considered as mid. So this is considered as mid. Mid equals 4, nothing but now we will square this one. This will be 4 into 4, nothing but 16, and 16 is greater than 8, man. 16 is greater than 8. So what we'll do, we'll completely discard the right half. So completely we will discard the right half, right? So now what we will do, we will consider 2. We will try mid 2. So now we have 4. We can just try with the 3 2, right? 3 2, this one, 3 and 2, right? So 3 to 1 we can try with. So we will try 2. Now this time we can just go with this one, what do we call, let's try with the 2. Mid equals 2. So here mid equals 2, next what we'll do, we'll go with the 2 square, nothing but 4 here, nothing but 4 here. 4 is less than or equal to 8. 8, right? 4 is less than 8 basically. This satisfies the condition. 4 is uh, less than or equal to 8. We will store 2. Now we will store 2. Will store 2, and we will continue with the search. We'll continue, right? So next we will try with 3. So we have tried with, first we tried with 4, then with 2, then with 3. So now we will be trying with the 3. So this is not possible, and we have, this is possible, and we have stored 2, and let's try with the 3. 3 is nothing but, we'll go with the 3 square. 3 square is 9. 9 is less than or equal to 8. No, this doesn't satisfy the condition. 9 is greater than or equal to 8. Greater than 8, sorry. Yeah, so this doesn't satisfy the condition, and this we will stop here. We'll stop here, means we will discard right basically. Here in this case, we will discard right. Well, we'll be discarding right. So we will end the search here. We'll end the search here. This is also not possible. We'll end the search here. The last stored valid number is 2 here. This one, right? The last stored valid number is 2, and we will return 2 in this case. This is how we'll be making use of the binary search for this particular question. So the output that we got here is 2, which is equivalent to the output that they have given for the example 2 in the question. So our approach works absolutely correct. Our approach works absolutely correct in this case, right? So let's quickly discuss the complexities before writing the code. So what will be the time complexity for the code that we'll be writing in the future? The time complexity would be big of logarithmic n. So just give me a second here. The time complexity would be big O of log n. So why it will be big O of log n here? So because we are making use of, or we will be making use of the binary search, which reduces the range logarithmically. So overall time complexity would be big of logarithmic n. And what would be the space complexity here? Space complexity would be big of 1 as well. Why it is big of n? Because we are making use of the constant space. We'll be making use of the constant space. So the space complexity would be quite obviously big of 1. The time complexity would be big of logarithmic n, and the space complexity would be big of 1 for the code that we'll be writing in the future, right? So I hope the complexities part is completely clear as well. I hope the complexities part is completely clear as well. Right. So now let me do one thing. Let me delete this one. As we are completely familiar with the complexities and the approach, let's start writing the code. Let's start writing the code. Initially, when x itself is 0, then we have to return 0. So that is the edge case, right? Square root of 0 is always 0, right? That's what initially. Let's go with, if x equals 0, then we have to return 0. This is one of the edge cases, right? So next, let's do one thing. Let's go with the minimum possible square root, nothing but 1. Let me assign low equals 1, binary search here. And max square root for x greater than or equal to 4 will be less than or equal to x by 2, right? Will be less than. That's what we need to check. First we are getting the square of that number, and then we are checking whether it is less than or equal to this one, x by 2, right? So here in this case, how can we articulate that one in the form of code? Let's initialize high here, this one to x by 2. This is fine. So I hope this part is clear. The next part here is, we will store the last valid square root, nothing but answer or result variable. So this one to the 1. We are storing the last valid square root here. So let's initialize this one to 1. Now let's perform the pure binary search here. So while low less than or equal to high, so this will be int mid equals low plus high minus low by 2. This is fine. So we are to just prevent the overflow, we'll be calculating the mid here. So now let's make use of the division instead of multiplication to avoid the overflow. What kind of overflow we are avoiding here? When mid less than or equals to x by mid. So we are avoiding the overflow mid less than or equal to x by mid. Instead of multiplication, let's make use of the division here. So here this will be, if mid less than or equal to x by this one mid, then what we will do, let's assign the answer to mid, and also we have to move the left pointer or low. Here in this case, this will be left equals mid plus 1. So else what we'll do, this is for the condition if mid is the valid candidate, then we have to assign the answer to mid. Then we have to try for a bigger square root. Then we will be trying for a bigger square root. We are moving the left or low pointer to the right, means mid plus 1, one step. Then we have to try for the smaller values, means we are moving the right pointer to left side, means high equals mid minus 1. This one I can write here, else high equals mid minus 1. So this is it for the code. We are done with the code. So the last step is, I forgot to write here, we have to return the floor of the square root, right, accordingly with the question. So let's we have to return the answer here. So let me format the code once and let me hit the run button. I hope this works, man. This has to work. Let's see. Yeah, here you can clearly see the sample test cases are getting passed. So let me hit the run button. What happened here? Sorry, let me hit the submit button. Just give me a second here. Yeah, I hope this works for all the test cases. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? The code works absolutely correct on this case, right? So I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.